Okay, so welcome guys. This is Roshan. I'll be the instructor for this workshop on microservices, Docker, and containers. Before I get started, I'd like to introduce myself. So I have overall 16 years experience in IT. Predominantly, I've been working into development and performance engineering, Java performance engineering. From last 6 to 7 years, I'm completely into DevOps and SRE, looking into production issues. Okay, so that's what my expertise is. My expertise into building the reliable, highly available applications, scalable applications, and making sure it in production we are running without any issues, no downtime. So no like every all the SLAs, meeting all the SLAs. So we try for that. So right. So that's what about my background. So on this particular workshop, this is what we'll be looking into. So we'll be understanding uh, this monolithic application. What do we understand of monolithic applications? How it is different from microservices? The disadvantages of monolithic application over microservices. How microservices helps in scaling up better, deploying better. So we'll look into those aspects. So before I get started, right? So I would like to just understand about my audience here. I believe most of us are here from performance background because I that's what the audience have been getting. If anybody, I hope is that be a correct statement? Could you just help me understand so that I can talk in accordingly?
Yes.
Perfect, Ram. So Ram, you have same performance into background and engineering into cloud and DevOps SRE kind of a responsibility.
Yes.
Okay.
Yeah,
How about
muted also as well.
yes, Ram, go ahead.
No, I'm saying from my side also, I need to document.
Okay, great. How about others?
Even I'm also from performance testing, so all good.
Okay, perfect. So on that note, okay, so we'll understand. So why we are we talking about this, right? That's the main question. Why microservices, monolithic applications? You all know that you have been working on your applications, and you know it scales well, meets the SLA, no problem, right? But we need to understand deep dive to understand the differences between the monolithic and microservices. Then we'll understand why we are stressing so much, or the industry is focused on so much on the microservices, right? So okay, so just to get started on that part, so let's say consider first we need to have the understanding what is monolithic and what are microservices, how they are different. Once we have this understanding, we'll all understand exactly why, and you would be able to make a difference. You'll be able to make your point that which is better from a reliability perspective, from the availability perspective, which one would be better, right? From the monolithic or microservices. So let's understand that. So consider that you have a three-tier application. Just imagine. Okay. So you have a three-tier application. We call it, let's say, web server, could be, right? Or we have the application layer where we have all the business logic. And let's say we have the database layer where the database, all the records, tables are stored. I would like to take your focus on the application layer. Okay. So just focus on the application layer as of now. And whatever I'm showing you in the slide is all about the application layer. So my application, let's say, if I have a bookstore application, just imagine. Okay. And let's say I have got modules. I have got 4 modules, or I can have multiple modules. Consider a Flipkart application. I can have mini modules. I can have modules for my electronics. I can have modules of my other kinds of items, kitchen items, some travels, different kinds of module, billing, user management, user data. So I have different kinds of modules in the application. So let's say this bookstore application, I have this accounts, payments, shipping, and inventory, let's say. So now, in what do we mean by modules? So a part of the application where basically if you look from the code perspective, from the application perspective, so let's say consider a Java application. So how do you write a Java application? You start with writing let's say project, right? You start a Java project, and then we create a kind of a package, right? And then in that we can get multiple packages. For a particular package, we write a class, and in that class we write methods, right? So this is what usually the way we write a code, right? That's how we basically write the code. So I'm going to just repeat that for others to consume. So let's say we start with a project. Java project could be, or it could be a Maven project as well. It's good to have a Maven, right? So let's say start with a project, and then I will, in that project, I will write packages, multiple packages. I can have packages 1, I can have packages 2, right? Like this kind of packages. In this package, I have class 1, I may have class 2, right? Now this class can have multiple methods. In this class, this class can have M1, M2, M3, like method functions basically, and so on. Again, this method will have again same kind of modules. I will have M4, M5, M6, and so on. I will have modules in that. The same thing for package 2. So consider this packages as one of the modules. So I have this module as one module, other module like this. And when we package it all together, we package as a single jar unit, single jar file. See, you write the code like this, right? And then how do you deploy the code? You basically create an artifact. That's what you do. That's what we do, right? We create an artifact like .jar file. Similarly, just imagine the same stuff for package 2 as well. You can consider package as module 1, or multiple packages can come in and call it one module. Again, it all depends. I'm just, for the simplistic, I'm just telling this is my module 1, right? And this is my module 2. Just keep it simple. So that's what I'm going to write the code. And at the end, when you build this code, right, you get one jar file, or you may get war file that you deploy on some application server like a Tomcat or WebSphere. You deploy that and your application is up and running. Now the question is how it is monolithic and how Microsoft, how it is different. What is the difference? The difference is in the code deployment. If you deploy all the modules together, basically when there is a huge dependency, there could be a case while writing M1, I could have called M6, or I could have called package 2 methods, I could have package 3 methods. I am calling the functions anywhere and everywhere across the modules, across the packages, across the class. There is a huge dependency. In case of monolithic application, this is what happens. There is a huge dependency. That's what the differentiating factor is. From a code perspective, once you understand from a code perspective, it's easy to understand, right, how it is. So monolithic applications. So I'm calling the functions everywhere and anywhere. Anywhere and everywhere across modules, packages, modules or packages, anywhere. Could be any class, anywhere. So there is a huge dependency. The word is there is a huge dependency. What is the problem with this dependency? You know, the problem is this. Let's say some of the region, let's say M2 is not working for some issue. Something happened, some bug came to one of the functions. Now tell me one thing. If you have understood this definition, huge dependency, the functions are being called anywhere and everywhere across modules, packages. Now, if there's a problem with one function, do you think it can impact my other functions, other modules, eventually my entire application? Do you think so? If there is a huge dependency? Yes? No? One function issue, one issue with one of the functions. Do you think so, everybody? So with one function can have the potential to bring the entire application down, because the functions are being called, right? In M5 we are calling M2, or in module 2 I'm calling M5. There's a huge dependency. So one function, one bug in one of the functions can have the potential to bring my application down, can disrupt my application functionality. And that's why whenever we talk about monolithic applications, we don't do frequent deployments. You have never seen, right? In your organization, just try to relate with that. you would see quarterly release, right? Or half yearly release. We don't do frequent deployments. We don't do. The reason is this, because we keep on accumulating the bug fix, and then we release a quarterly major release. That's what we do. And that's when performance engineers, performance testers are being asked to do a regression test to check whether the performance has deteriorated or improved or consistent, right? You guys would be involved in those activities. That's what the concept is. So did this does the code change impact my performance, right? That's what the monolithic applications is. So there is a huge requirement to segregate this and make a different kind of application. Segregate, make the, so the problem, right, the one issue with one function can have the potential to bring my application down. I would never like it. Nobody would like it, right? If it issue with one function can bring the entire application down, we need to take care of this. How to take care of this? Simple. We need to remove the dependency. We need to make it independent. So when I say independent, the modules that I'm writing here, I'm writing some modules here, right? I'm writing different modules here. In module 1, I have written so many functions, and 10, 20 functions. How can I remove the dependency? Only way is to segregate the code. No other way, right? I need to segregate the code. That's how I can remove the dependency. One second. Let's say I have written functions here. I have written M1 functions, multiple functions I'm writing here. Hold. So just imagine, okay, I'm writing M1, I'm writing 10, 20 functions here. Let's leave it for now. What I'm gonna do, 1 minute. So we need to sort this out. If not, this is going to create a problem, and it will have, see, as a customer, if nobody would like to have a downtime, no, we should do everything possible to remove the downtime, right? And that's what we should try to aim here. To, let's say I have written M1 to M20 here, M21 to M50 here, or here I have written M51 to M100 here. Methods I'm showing you, M101 to M200 here. So the function, the methods I'm writing, and I'm calling the functions anywhere and everywhere. I need to stop this. I should make all these guys independent. I should not call the functions. If there's a problem, in worst case scenario, what will I achieve if I make it independent? Tell me. Just think about it. Think this through. If I make these guys independent, accounts independent, payments independent, shipping independent, inventory independent, I'm not calling the functions. Whatever the function I'm writing, only for this guy, I'm not going to call the functions. So at least the issue with M1 can only impact this module. My other modules will still work, just as there's no problem at all. All the latest applications, Swiggy applications that we have, Swiggy, Uber, Ola, all these applications that we use right now, right? It's all based on microservices. And that's the main reason that now, let's say, you have a notification, right? You have a notification module. Now tell me one thing, if in Swiggy or in Uber, notification module, which is at the top right corner, and you get a notification whenever you order your food or book a cab. Let's say if I tell you notification is not working, if notification is not working, you cannot order your food or you cannot book a cab. It doesn't make any sense to me. I will definitely ask, what notification has to do with my other functionality? We are asking these questions because it's a microservices. We are thinking about the microservices. Earlier, this was not the case. everything was deployed together, and there were methods, functions being called anywhere and everywhere. There was a huge dependency in case of monolithic applications, and that's what we are trying to solve in microservices, making it independent. So microservices, right? I have been talking about microservices. So you can ask Roshan, give us few real time examples that you see microservices. Yes, we have many examples. Let's say if I have to just top of my head to make my trip, you go to make my trip, and you eventually book a flight in Indigo or in Air India. How it is possible? It's all about do you think the Make My Trip has the Indigo database access or Air India database access? Nothing. Microservice, Indigo is a different application, Air India is a different application, Make My Trip is a different application, but they are communicating. If Make My Trip is down, it doesn't mean your Indigo would be down or in Air India would be down, right? Microservices, and the integrations is happening because of we are calling the APIs. Eventually we are calling the APIs. That's what. So I have made the microservices, the modules, independent. So I'm not calling the functions. First of all, I made them independent. That's the important word in the context of microservices. Independent. It's not dependent. And if one microservices needs to interact with other microservices, I will get all the information through REST API call. If let's say account has to interact with payment, I'll call upon APIs which have been exposed in this module. How Make My Trip calls API of Air India, Air Asia, or Indigo to get the flight details or to book a cab or to book a flight. How they are making the call, API call. It's all about the API call that is being made. API call. So that's what the microservices is. I hope it is clear, guys. What is the difference? The advantages are plenty in the case of microservices. Consider this your bookstore application. Consider the same applications. So you have made it independent. Your accounts, payments, shipping, inventory, they're independent. If accounts has to get some information from payments, I will call the API and get the information. API calls, REST API, RESTful API we call it, RESTful API. I hope you guys understand API calls. Some of you would be testing.
Is it the independent API is a microservice?
Correct. That's what, right? So what is microservices? So when you break the same monolithic applications into smaller pieces, you had a big monolithic applications where you had the code in the same application server, where all the code was packaged together, built together. You get only one jar file. Now you made it separate. Now you don't have only one jar file. Now you have got 4 jar files if you are writing all the code in Java, or 5 jar files depending on the way you are defining the microservices. The monolithic, it's the same application, same module is divided now into microservices. And now earlier where I was having one jar file, I have got multiple jar files, multiple deployment files now, because all are packaged separately, deployed separately. The methods are not being called. I'm exposing the RESTful endpoint if they need to communicate. That's what microservices work. And that's what they give you reliability. They make highly available applications. You will not have downtime. If one module is not working, it's not going to impact other modules. Highly available applications, reliable applications, resilient applications. They're all the properties of microservices because of this core architecture, because they are not highly dependent. They are independent, in fact. Okay, I'm making sense, guys. It's been 20 minutes I've been speaking. Am I making sense, everybody?
Yes.
Yes, sir.
Very good.
Great.
Yes.
Perfect. Sounds good. So the next question comes, right? Where should we deploy this? And what are the advantages? First of all, let's talk about the disadvantages. Disadvantages of microservices. Advantages are very few. There are many more disadvantages. Now, if we have understood, we can easily understand this. So yes, advantages are IDE support, integrated development environment. So if you are, let's say, you started with module 1, you started with Java application, Java with Java technology or Node.js technology or Go, any technology. So you will continue to use Java for other modules also. That's the, I would say, the disadvantages of, okay, let's say advantage. It's in the favor. Understand that. So it's in the favor. So you don't need to know multiple technologies if you're dealing with microservice, if you're dealing with monolithic applications. But now I'll tell you the advantages of microservices. The microservices, one microservices, since I'm not calling the functions, one microservice I can develop in Java. This is the advantages. So I can select the best technology available for that particular microservice. See, what is microservice? It's a sub application. Just keep it simple. Microservices are nothing but the sub applications. The smaller the subset of the bigger application. Bigger application, your monolithic applications. Consider a feature, a function, independent function in the bigger applications as microservices. So I can develop microservices in different technologies because I'm not calling the functions, right? That's why I have to expose the RESTful endpoint. I can do that in any technology, in any language. I will expose some GET call, post call, right? I can expose some RESTful endpoint, and the other guy can call it and can update, post, get. They can get the details. I can select the technology as per the suitable requirement, as per my requirement, specific requirement. That was not the case with most applications. If I have selected, let's say, Java, I have to continue with using the Java. Even if it doesn't gel well or it is not giving the best of the performance, still I have to select. We have to continue with the same path. Other disadvantages, I'll tell you, as a performance engineer, you relate that. Let's say you have a monolithic applications where you have multiple modules, right? You are running a performance test, and let's say response time of one of the transactions is higher. And when you looked into that, you found the CPU is the contention. Because of the CPU utilization, high CPU utilization, that transaction response time is higher. So now, do you have any mechanism? It's that transactions belongs to one of the modules. Let's say M2. In monolithic application, do you have any feature that you can scale up only the M2 infrastructure? Only specific to M2 infrastructure? Do you have that option in monolithic applications?
No.
No, because it's a one jar file deployed on one application server. You will have to scale up the entire application server stack, entire thing. Even though other transactions are perfectly fine, it's not creating a problem. Other modules, transactions, the applications, the features are all good. They are not creating the problem, but you will have to increase the complete application stack. So, but here I can, if microservices 2 and some transaction, one of the API is not working fine, I can just scale up this guy. I will not touch other guys because I have got different deployment files for these microservices. I'm deploying it separately. The servers are different. I'm deploying this in one kind of a server. I'm deploying the other guy in another kind of server. The server, there are different kind of applications. Server 1, I'm deploying, this is VM1, I'm deploying. This guy I'm deploying in the other VM. I'm deploying it separately. In VM1, I'm deploying this. In VM2, I'm deploying this. In VM3, I'm deploying this. I'm deploying it separately. I can increase the capacity of only with this VM. I will not touch the other VM. because I have got separate jar file. If I am writing in all the Java code, I will get Python package here, I'll go package here, Java jar file here. So I'm deploying it differently. So that's one of the advantages. One microservices is down or have some issue, it will not impact the other microservices. That's again advantages. That is in the favor of my being highly available, highly reliable. My client would like if I'm highly available. Even if let's say notification is not working, I'll say fine. My core functionality still works, right? I would not be bothered. I would ask my team to fix it, but I'll not be like panicking or losing my control, right? So I'll not lose the business, in fact. Next question comes, where should we deploy this? That's the key point. Where should we deploy this? So, you deploy monolithic application on a VM, virtual machine. You deploy that. But these microservices are sub applications. They do not require the VM capacity. Where should we deploy this? How many of you heard the word containers? I just want to know from all of you. Have you heard the word containers? Have anybody used Kubernetes?
Yeah.
Yeah.
Okay. Who was that? Sirisa? No.
Yes.
And me.
Okay, great. How about others? See, only Sirisa is using her containers. Have used others?
I'm using.
That's great. DZ. That's great. So now those who are using, I would like you to comment. How important are containers? I would like you to tell everybody. Yeah, I'm going to tell you. I'm going to tell everybody. And what is the main advantage? Do you know what is the main advantage of using containers?
They can scale up and scale down independently.
Yeah, that's what, because I'm deploying the microservices there, so obviously I can do that. But why containers? Why not VM? Even if I deploy microservice one in a VM, I can scale up and scale down independently. But why only on the deploying on the containers, not on a VM? Is that my question?
So we use
For
them whenever it's necessary, and other times we free up the space.
So VM also same thing I can do.
VM should need something like separate operating system on our main one. Like we need some hypervision or something like that. Hypervisor or like that. For container, we don't need a separate operating system. So it's so yeah. This is what I can recollect.
Yeah. You're almost there. You're almost there. Thank you.
So we pay for what we use.
That's fine, Tawhid. So you pay for what you're using for VM basically, right? I'll tell you. So hear me for next 50 minutes and you will thank me in your career. So now, here is what you should know. I know the information that you have. You may have some idea, but I think you're not able to articulate that well. Let me help you. So when the software development started, right, deployment started back in 1980s. Okay, there was no concept of a VM, virtual machine. There was directly on the physical server because there was no concept of virtualization. There was no concept of, let me write this. So that is about the monolith and microservices. Now here is what understanding of the VMs and containers. What you should know. I should have ideally one slide. Okay. Let me just take this. See, when the software development started, right, 1980s, we used to deploy the application. So we used to directly deploy this on the physical server, directly. Physical server. Back then, there was no concept of virtualization. there was no concept of VM, virtual machine. I hope everybody is aware of virtual machine here, right? If you're aware of AWS, we have this service called EC2. You can go to EC2 and create a VM instance, we call it. Node, you can call it. Whatever you can just call it. People call it with different names. Like EC2 is one of the service, Elastic Compute Cloud, if you're in AWS. So that's the VM. And there was no, because of, we are able to create EC2 instance because of the virtualization. But back then in 1980s, there was no such concept of virtualization. It came around early 2000 or end of 1990s. So people used to deploy the application, that tiny little application which they used to develop on directly on the physical server. And this physical server used to have huge capacity, hundreds of vCPUs, 400 GB RAM, 500 GB RAM, and let's say some tiny little application, few KBs, MBs applications. Wastage, huge resource wastage, huge unutilization of resources. We are wasting resources left and right everywhere. So then 1990s, around end of 1990s, revolution happened. I would use this word revolution in the IT revolution. Because see, the cost is at the center. Everybody wants to deploy the application with the least possible cost, infrastructure cost. This virtualization, what happened? On this physical server, somebody used the word hypervisor. On this physical server, on this very physical server, we installed something called a virtualization software. What we did on this physical server, we installed something called virtualization software. Hypervisor is one of the virtualization softwares. Virtualization, which helps us virtualize the physical server. And once I install virtualization software, hypervisor is one of them. There are many other virtualization softwares. Hypervisor is one of them. We have Oracle VirtualBox. We have VMware softwares. We have Hyper-V from Windows. We have multiple such virtual software. We install that Hyper-V. We install either one of these any one of it. We install, and basically we could create VMs once we install this virtual software. This is nothing but the virtual software. Once we do that, we could create multiple VMs. VM1, VM2. On the same physical server, we could create multiple such VMs. VM3, VM4, VM5, multiple of different shapes and sizes. Multiple VMs. Now I can deploy multiple applications. Earlier I used to deploy only one application, but now I can deploy multiple applications. Once we have the VM, we call it VM1, VM2, VM3. All are VM1, VM2, VM3, virtual machine. We can deploy as part of 3-tier application. We can install web server here, app server here, database server here. We can deploy that directly on the VM. But when it comes to the microservices, these VMs is highly sized, more sized, I would say. We would waste resources if we deploy this microservice on the VMs. Basically, we would waste resources. Just give me a minute, guys. Somebody at the door. Just give me a minute. Okay, I'll be back. Right, guys, I'm back. So these microservices cannot be deployed on a VM because see, whenever we were running 3-tier application, we will observe that the CPU utilization was not reaching more than 25% to 30% of in the VM also. In VM also we were wasting resources. The CPU utilization of a VM was mostly hardly used to be 30 to 40%. That's all. Overall, you can relate to your application also wherever you work. Hardly to 30-40%. We are not fully utilizing the resources. So how to make sure that we can use the CPU, the cores, and the memory of the VMs? That's when we will be able to optimize the cost. We'll be able to deploy the infrastructure with the least possible cost. And that's where this containerization came. Containerization. So back in 2015, one technology came, and again this has revolutionized. Same way the VMs revolutionized, the same way containerization has revolutionized this. So the main purpose, objective of containerization is to create containers in a VM. So let's say I've got three VMs. Okay. 1 second. This, guys, I'm back. So this containerization has revolutionized the IT. The way we are going about the resource optimization. See, you use performance or security, any domain you can work on, but the cost is at the organization level. The CEO, the CFO, CTO, everybody for that cost is the most important factor. And they would be interested in the technology where they can spend less for the same business scalability, for the same for servicing the same volume of traffic. If they can spend less, they would be interested. The technology, they would like to adopt this technology, and that's where this containerization is so welcoming in the resource utilization that every company all across, they're adopting this, because this directly brings down the application resource, the infrastructure requirement. Because this 30 to 40% the resource utilization, we can take this to maximum fullest possible utilization in a VM. So what is the idea? What is the idea of containerization? So we have a VM. Okay, so let's take this. So I have been talking about this, but let's understand what is this containerization. Because we all understood the virtualization, right? Guys, are we on the same page on the virtualization? Did we all understand what it is? How we create VMs? Yes, please give me a thumbs up. Yes, VMs part.
Yes.
Everybody, clear? Now look at this containerization, how we work. Okay, so we take one VM. In that VM, we already have an operating system. Without operating system, a VM cannot run. You know that. We have an operating system in a VM. This is the operating system. On top of this, we are going to install a container engine. A container engine. On top of it, in a VM, we're going to install a container engine like Docker. Docker is the most popular container engine. Docker is the most popular container engine. In a VM, we will install Docker container engine. Once we install that, we can create multiple containers in the same VM. So don't think, somebody was telling, that we create a VM, we can create a container without VM, without OS, nothing like that. Basically, in a VM, you create container. You virtualize the operating system of a VM, and that's where you create containers. So you virtualize the VM and create containers. That's what we do. That's what we do, guys. So that's what we do. Understand this. This is what we do. That's how we can create containers. We can create multiple containers in the same VM. Multiple containers can be created. And we can make sure that the VM is fully utilized. And then if we need more cores, we can go ahead with another VM. But the containerization, the main goal is to optimize the cost. Optimize, make sure we are fully utilizing the VM. So what are we installing on these containers, guys? Containers, I told you how we are creating. But these microservices that we were discussing, right? So now these microservices became the ideal choice. These microservices became the ideal choice in getting deployed to these containers.
So each and every container having multiple microservices or single microservices?
One-to-one mapping.
Okay, one-to-one mapping. Okay.
So basically, if you look at the broader picture, I would like you to understand the broader picture here. If you look at the broader picture, so we have monolithic applications. We broke the monolithic applications. We came to microservices. On the VMs, we create the containers, and that's where these two microservices and containers combine. Able to understand these two flow of the things here? Okay, so let me just recap that. What did I just mention? I mentioned this. So we have this VM concept. So just consider these two tracks. Consider these two tracks. One track is this of application development, the way we are going about application development from monolithic to microservices. So earlier, we were monolithic applications. We were developing monolithic, and now we are developing microservices. Same track we have for the VMs and containers. We have this VM, virtual machines, and then the containers. And now, basically, we deploy monolithic applications on the VMs. We deploy microservice applications on the containers. Keep this in mind. So the technology has been advancing. The technology advancement, monolithic. Now we're talking about microservices. We all understand the importance. That is on the architectural front. That is having, and that's having a separate advantages here. This guy is having a separate advantage. This guy, this track, and this is having a different advantage. This is on the cost optimization. This is on the application availability, architectural stability, and this is on the cost. And when they merged, this has revolutionized the IT. Basically, everybody, every organization is developing microservices, and they are deploying on the containers. That's where we are in. I asked everybody 15 minutes. Did we understand the importance of this 15-minute discussion? Who all understood this? Everybody? Are we on the same page?
Yes.
Did we had a better understanding now of the things that you are involved in?
So where is the Docker coming in here? Docker.
Without Docker, you cannot create containers. So without hypervisor, you cannot create VMs. So without Docker, you cannot create containers. So we are installing Docker. So this marks that I did right that time. This is the container engine.
Okay. Yeah.
We are installing
Container
on the
engine.
container engine.
Okay.
So without installing the container,
That is a OS independent.
on top of OS, on top of a VM, we have to install this, and then only you can create containers. Okay, I'll do one thing. Okay, let me do a demo. I'll do a demo, guys. Hold on, nothing to worry. Let me do a demo. I'm gonna create a VM. Have we used, anybody has used AWS to create a VM? EC2 instance? Anybody here in this group?
We are directly using EC2 instance created by the DevOps team.
Yeah, that's fine. That's fine. But from a knowledge perspective, have we tried creating an EC2 instance on your own? This is my AWS account.
Yes.
This is my AWS account. I'm in this Mumbai region. I can create EC2 instance. I'm coming up with a course, guys, that you could be a DevOps engineer. You can talk to DevOps engineer much in the same level. In fact, much more advanced level. I'm here with a course. I'm coming up with a course for an SRE vision for you to become an SRE engineer. SRE is a combination of performance engineer, DevOps engineer, and production expert. I'm coming up with the course. So I'm coming up with a course where you get to learn all of those things. You get to learn cloud, hands-on, like a DevOps engineer, microservices, all from a performance perspective, and all from a production reliability, because that's what matters for any customer. I'll talk about the course at the end. Okay, that's I'm coming up with. So you can go over the course syllabus and you can attend the demo planned next week. You can also attend my one of more demos coming tomorrow on AWS architecting. So please plan to attend that. Please contact Isha Training Solutions. They would guide you to attend one of the demos that I'm coming up with tomorrow. Let me, yeah, guys, come again.
At what time tomorrow?
Same time, 7:30 p.m. IST. The same time we have this demo, right? So please contact. Okay, let me, guys. Before I do a hands-on, okay, let me just, since I'm already talking about this course. So, guys, this is the course I'm coming up with. This is my course that I am taking up with Isha from last 3 years. Okay, you can enroll. You can go over the course. Okay, enrolling and all is the secondary part. If adding value add to your career, to your perspective, so definitely you would. So try to go with this. So I'm coming out with this course next week, starting next week, Saturday, with the course. Demo is on the next week. We have this workshop today and tomorrow as well. Tomorrow on the AWS architecting, and this demo on the course next weekend. And there you'll understand what all we are covering. We are covering cloud, everything hands-on from scratch. Like somebody told, right? It is being developed by DevOps team. Why we are relying on them? Yeah, it's part of the company, that's fine. If they have some special permissions you cannot create, that's fine. But you should not think or tell that I don't know. Right? That's what I'm trying to tell you. Because we should all know. In the current market trend, we should all know these things. A performance engineer is expected to know all of those things. Okay, so this about the cloud, guys. AWS cloud, I'll be taking up with this course. I'm talking about the Linux. My tagline is this. Okay, this is what the tagline is. Get as comfortable with Linux as you are with Windows. That's just an operating system. So we'll talk about Linux. We'll talk about what is SRE mean, the roles and responsibility. DevOps, monolithic microservice architecture, all about the containers, not just the container, but the Docker and Kubernetes. You know, Kubernetes, who invented Kubernetes? Any idea? Who has invented Kubernetes? Who originated this? Google. It's Google. Anybody who disagree that Google handles the traffic efficiently, the most efficiently traffic, anybody who handles that traffic, the volume of traffic better than Google, I don't think so you would agree with anybody else name. Google has the highest traffic and they handle traffic because of this Kubernetes. Kubernetes play a very important role in the infrastructure optimization. It's the bigger brother of Docker. I would say they're not just the bigger brother, grandfather of Docker. Much more thing. We'll talk about, guys, DevOps. What is DevOps? We'll talk about automation. So lot more things. This course is full of observability, Kibana, CloudWatch, Prometheus, Grafana. This automation, using Ansible, Terraform. This course is full on. Okay. So I'm going to give you this link. Okay. So I'm going to give you this link. Take your own sweet time to go over this link. Okay. I'll complete the demo part. Please. So use this link. Okay. So keep this link handy, guys. Okay. So guys, back to my demo. Okay. So I was explaining you something, right? This guy. Microservices, containers. How do we create containers from a VM? Let's understand this. Let's do a demo. Everything is all about demo. So I'm in a VM. I'm in a cloud, AWS Cloud Console, and I'm in a Mumbai region. I'm going to create a VM. So to create a VM, go to EC2 and just create a VM, virtual machine. Hardly takes 2 minutes. Just calculate just keep an eye on your watch, and hardly take 2 minutes to create. Not a big deal at all. Creating a VM is just a cakewalk. Give a VM name, whatever the VM name you want. Bootstrap, just give a name. And select an operating system. Let's say I selected Ubuntu. Select the core and the RAM. I'm selecting the list possible. 1 vCPU, 1 GB RAM. List possible. Select a key pair, because you need this key pair to log in. So I'll call it Isha Workshop May 2023. I'll just name it like that. I'll install the PEM format. This is the key pair I'm giving. I'll talk about this guy. Right now I'm going to just create it. This is the VPC. I'll select the security group. I'll just create a security group by default, launch Visual 2. Create a security group. 8 GB disk where the OS will be installing. Just check your time in your watch. Hardly would take 30 seconds to get a VM, and I'll just launch in 10 seconds. That's a VM for you. This is a VM. And you're telling this DevOps guys do that, and we don't know why. Simple. So this is a VM. Instance ID. This VM has got public IP, private IP. I'll just wait for a few seconds and make it running, and I'll connect to this VM. To connect this VM, I'll just click on this guy, click on connect. You can use PuTTY, you can use MobiXterm, you can use Instance Connect. In AWS, you have this beautiful option. You don't need any other third-party client like PuTTY or MobiXterm. You can directly connect. Done. I have logged in to a VM, guys. This is the VM. I have logged in already. This VM has an operating system, Ubuntu. I can be a root user. Right now I'm Ubuntu user. I can be a root user. I can install Docker with a click of a button with just this one command. I'll update the packages first. Like how do you do Windows update? Similarly, I'll do this Linux Ubuntu OS update. I'm installing all the packages, updating the package over from the internet. Updates done. I'm going to issue one command. Do I have Docker installed? Check this. I don't have Docker installed. To install the Docker, you have to just use this command, apt install docker.io. That's all. -y. Just do this and your Docker is installed. So I have a VM. I created a VM. I installed a Docker container engine on this VM. And now I can create containers, multiple containers. I can create a container for web server. I can create a container for app server. I can create a container for database server on the same VM. I can have web server, app server, database server on the same VM. 3 containers. And guys, what is the resource, cores, and the RAM of this VM? Anybody? I just told you some time back. What was the core and the RAM of this VM? Check this out. What is the core? You guys are smart enough to read this? What is the core? 1 core. What is the RAM? 1 GB RAM. What is the disk? 8 GB disk. And I can create 3 containers. Can you imagine? I can do that. I'm going to just quickly run one command and I'm going to show you a container being created. If you do Docker PS, it will show you the running containers. Right now, I don't have any containers. I will quickly create a web container. So I'll do Docker run -itd. I'll explain this sometime. -p port mapping. I'm doing 82 port of the host maps to 80 port of the container. HTTPD. So HTTPD is the web server container. Okay. I'm creating a container. I'm installing this image of this container. HTTPD is the web server container. And if I do Docker PS right now, there will be one container running. One container running, guys. And I access that container using the 82 port of the VM. I can just check this. If I do ls of -i -p -n grep.listen, this will tell me what is running. So in 82 port Docker is running. I have listed all the containers. I can use netstat also, nothing big deal. Netstack. So I'll just leave it. So I can use lsoft or netstat, anything would work. Okay. So I can see 82 port is deployed here and I can access this web container on port 82. So I need to basically, there is a concept of security group in the VM. You need to open this firewall. Since I have opened port 82, you need to go to the security group and you have to open the port 82. Then only you can access the web container. So inbound rules, there's a concept in the cloud. I'll explain that, guys, sometime. It will take some longer. Let me give everybody the access. I'm just giving HTTPD container access. So I'm just opening port 82 here. And I can now use the public IP of the VM and the 82 port to access my web container. This is my web container, guys. Please check this out. You will also get this. Check this out. Are you getting the same page, everybody? So last part, guys, I use some commands. Okay, I can give you the command, by the way. Is it accessible, everybody? I can give you the commands what I have used. So you can try on your own.
Yes.
Recording. Good. So you'll have the recording anyway. So I'm going to give you this command. So you guys can practice this. But we'll explain this. We'll go over this command in greater detail in the course. So basically I'm running as a container, one container, guys. One container, Docker PS. And look at this web server container to understand the footprint. How much core and the RAM this guy is taking in a VM is this. Can you guys check this? CPU and the RAM. This is what it is taking. I have so much of CPU and the RAM available, still available. I can create many more containers. I can create many more containers. Okay. So you just keep that in mind. So Docker PS will give you the running container Docker images, because since I downloaded the HTTP images, so this image is showing up. So if you go over the PPT, right, I have explained that this particular Docker container live. So I explained this VM and the containers. What is the difference? So in the container on the host OS, I have installed Docker, and you can create containers, right? And I've used this basically. So I've used Docker engine, and I pulled this image from hub.docker.com. This hub.docker.com has got a lot of images. You have the image of the MySQL, Tomcat. You have a lot of images in the hub.docker.com, and I have pulled the image and I have run this image to create a container. This is called Docker Container Lifecycle. So that's all I wanted to cover, guys, in this workshop. I hope you got a good learning. I could make a difference in your learning in this 1 hour. I hope that. Would that be a right statement?
Yes.
Great. Anybody has any question? Feel free to ask me any question in your career perspective, anything that you are working in your current organization that you want to ask somebody, could not ask anyone. Please feel free.
Yeah, Roshan, can you give some overview on the Kubernetes also? Like,
Definitely. That will take some time. We plan one more demo on Kubernetes. I'll take this, and we'll definitely plan a overview on Kubernetes. But I require at least half an hour to do that. But just to give you the answer, right? So see, Kubernetes. Why we use Kubernetes? So we use Docker to create containers, right? We did that. We used Docker to create containers, correct? You just saw. But it's not about, and we could able to utilize the resource better, optimize the resource. That's good. Successfully done. 100% marks. But this is not the only thing you require. Now tell me, I'm going to ask you this question. Do you want a feature which will auto scale the containers when the load increases in production? Do you want a feature like this?
Yes.
Yes, auto scale. Yes, you told yes. Do you want a feature that when you auto scale and when you create more containers, the load should get balanced across all the containers? Do you need that feature? I'll repeat that. So when you auto scale, you end up creating more containers. Yes. And when you have more containers, would you like all the containers to get load balanced, to get all the containers to have the same traffic? Traffic should get split, distributed. So auto load.
Roshan, one question, but load balancer will be there for that, right?
I'll coming that when it comes to container, right? See, on a VM, load balancer would be there, but on the container, there is no such load balancer for the container. On the VM, load balancer would be there. But in one VM, I can have 10 containers. So do you want the traffic, all the 10 containers in one VM to get equal traffic? Is that my question is. So you're thinking from a VM perspective. I want you to deep dive and think from a container perspective. How many containers could be there in one VM? Many, multiple? Yes.
Yes.
Obviously, multiple containers can load balancer guarantee that all the containers will also get the same traffic? Load balancer only will care about the VM, not about the containers. Correct? So you need the auto load balancing across containers. So now, one feature. Second feature. Would you want a feature if a container dies for any region? See, whenever you think of Kubernetes, right, Docker and Kubernetes, think from a microservices point of view. Think from a container. Don't think only from a VM perspective. That's the one thing you should do. Now, I'm going to ask you this question again. Would you want a feature if a container dies for any region and a new container get automatically created? Auto healing feature. Do you want that?
Yes.
Yes.
Okay. So you're all saying yes to everything. Now, let's say I have one image in container. I have one image. Now I want to upgrade. Let's say image is a version V1. I need to upgrade the V1 image to V2. So I may have some downtime. Do you want V1 to get upgraded to V2 without downtime? Would you like that feature?
Yes.
Okay. Who will give all these things? Do you think only container can give you, Docker can give you all of these things? You need
No.
a
Kubernetes
container
use.
orchestration engine called Kubernetes. Container orchestration engine. Docker is the container engine. Kubernetes is COE, container orchestration engine. This is what the difference is. I hope I could make a difference again to your understanding. This is what in 5 minutes I could explain you. We need to go in detail cluster creation and how do we create an auto scale and auto load balance. We need to talk about a lot of things in Kubernetes. Go attend any interview, okay? You would be asked questions on Kubernetes. It is that popular now. It's going to be the
Yes. Mm-hmm.
It's going to be asked questions. Somebody just means Sirisa just acknowledged that. So it's the most important topic. It's going to be the standard. Microservices are going to be the standard. Kubernetes is going to be the standard. Like, how do you know? Like everybody in IT is expected to know Excel sheet, right? It will be going to be that future in next couple of years. Kubernetes. Do you know Kubernetes? That's how it's going to be. Standard. Every deployment is going to be on Kubernetes.
Thank you, sir.
Sure, Sirisa. So that's all I wanted to cover today. We'll meet tomorrow again. Please contact Isha at this number. The link which I have given, save that link, and please contact Isha Training Solutions for the next demo. That next demo is planned tomorrow on the AWS architecting. I'll talk about AWS, and then we can meet next week, and then we can decide about the course.
Sir, can you copy paste the notes, whatever you have written in our meet chat? Yeah.
Sure.
Thank you.
Sure. Okay. Perfect. Okay. Please copy this before I cancel this. Thank you so much, everybody, for joining.
Thank you, sir. Thank
Sure.
you.
Thank you so much.